Guys, welcome to another Leetcode daily, and today we have minimum colors to get k consecutive black blocks. This one is an easy one, or it's not an easy one, it's just if you know the way, you're gonna solve it easily. It says you're giving a zero index string blocks of length n, and block can be either white or black. You're also given an integer k, which is the desired number of consecutive black blocks, only black, right? In one operation, you can recolor a white block so it becomes a black block, or return the minimum number of operations, such as at least one occurrence of k consecutive black blocks. So basically, we're given this string. We're required to find some sort of substring in it that has of length k that is full of white and black, but like the minimum number of operations we can do to turn white into black. So for example, say this one, right? The one way to achieve 7 black blocks is to recolor the 0th, 3rd, and 4th. So this, and this, such that you can get the 7 you want, right? In return, once the minimum substring, you can achieve that. Minimum operations to achieve the substring. So this is you can do this in like brute force approach, where you can actually do double loops, and for every index, just check like 7 ahead or k ahead, and start recoloring as you go, and keep track of the max, which is a solution, but it has a lot of repeated work because you keep checking. So for this one, you're going to check these, and for this one, you're going to keep checking as well. So there's a lot of nodes are being visited, a lot of indexes being visited multiple times. One other way to do this is actually a sliding window approach, where you have a pointer, or you have a window of size k, right? And a tip for you guys, a hint when solving this is, when I see sliding window, I see when it gives you like something of size x, it's probably a sliding window problem. So we basically have 2 pointers of size and then a window of size k, and what happens is we keep track of the white cells, we keep track of their count, and whenever we reach that window size, we're gonna update our res between that size, the size of the white cells in the window found, and the current existing minimum. So why the size of the white? Because the size of the white is basically the number of operations. So basically here we have this counter, which is a hash map, and all we do is we iterate over the block length, right, and we keep appending to the hash map. And then once it reaches the size of the window, then we're going to start upping the window. So basically, let's see, 1, 2, 3, 4, 5, 6, 7. So something like this, and then it moves, something like this, and then it keeps moving, something like this, and you get what I'm saying. And then every time we're going to update the size of the count of the white and the res, and then we're going to also move the L. So when we move the L pointer, the left pointer, we are going to check, we're going to decrement it from the counter, and then we're going to increment the L pointer. But we have to decrement the counter, either it's white or black, we have to decrement it. And then we return res. And yeah, so this is O of n time, pretty efficient. That's been it for this one. See you in the next one.